Let's break it.
Well, hello again. I'm glad to have you back. The next part of this little ongoing series that we have here will mostly cover the detector. Let me move this pin right here. Put it right in the way, not too bright. We're going to cover actually what's coming out of this, what's coming into here to this primary of the second intermediate frequency transformer. And then we're going to go over to the secondary and then over to pin 5 of the, this is a 3-part tube. This is 3 tubes in one. It's the detector, what a cool name, huh? The automatic volume control and the AF amp, audio frequency amp. Detector, ABC, or sometimes you see that referred to as AGC, automatic gain or automatic volume control, and the audio frequency amplifier. They're all wrapped up in this one little old tube right here, okay? And it all begins right here at the secondary of this the second intermediate frequency transformer, L4. What happens is we already covered the intermediate frequency comes in, goes out, gets amplified, goes into the primary, and right here it gets coupled across. Okay, it gets coupled across, magnetically coupled. It's a primary and secondary, a standard old transformer that's been tuned, or you can highly tune it for 455 kilocycles to be passed through. Now down at the bottom here, you also see a connection that comes down this way, this way. Right here is, we've got to get rid of the carrier frequency. Here's the carrier right here. I told you in the last video it changed from 650 kilocycles because we're looking at 650 AM out of Nashville. That's what we tuned in on this radio initially. And once it became the intermediate frequency, it went from 650 to 455 kilocycles, and this is it right here, all this blue stuff in the middle. Well, there comes a time in the radio where you finally have to get rid of that junk. The carrier has done its job. It carried it all the way from the radio station, all the way through here, all the way through here, all the way through here, and we're at this point right now where finally we have to dump it. We got to get rid of it. It's been a good friend. It carried the audio, okay? It carried the DJ's voice or the music from the record, and it carried it from the antenna all the way into the radio. So that's what we got to do. We got to get rid of this junk right here. Well, here's how it's done. Right here on the bottom of the secondary of this radio, of this intermediate frequency transformer, the carrier and the audio, that's called a modulated carrier, is coupled across here, okay? The audio will go this way. That's the little up-down stuff right here, up, down. This top line and this bottom line, okay? That's the audio. The audio goes this way, and it comes down, and it goes this way also, down through the volume control, okay? And then the volume control picks it off and sends it on up through this coupling capacitor, up to the control grid of this tube right here, where it is amplified. See, it says amp, audio frequency amp. That's how that's done, okay? Well, what about the rest of this stuff? Where does it, what happens to the carrier frequency, to 455? Well, it comes down through here. It also goes to over here, but it just keeps on and going through this capacitor right here. Keeps on and going, and boom, gets dumped to ground. You see that? Cool. The carrier goes this way to ground. The audio goes this way into the diode. Now pin 5 is a diode. That's the detector. Now there's 2 of these let me zoom in on there, and you'll see 2 of them in almost every tube you're ever going to look at. That's a detector. You're going to have 2 of these. Now, one of them is usually connected to ground, which in this case it is. It's connected to the same ground that the cathode is connected to, okay? Because one of them is not used. The other one is used. And what does that diode do? Well, it does what any modern diode does. It removes one part of either the positive or the negative of a sine wave. Well, let me set up something, and I'll show you what we're talking about here. All right, it's now time to split the sine wave, the audio. We'll just split it right down the middle like that, okay? Now, everything above the line is positive, everything below the line is negative. Now, all of this stuff in the middle, this blue stuff is gone. It's been wiped out. Remember now, I told you, it comes down from here, goes across to this capacitor, over to ground. All that blue junk is gone, leaving us with the positive and negative of the audio. Well, remember I told you that diode will remove either the positive or the negative? Well, what happens in this radio, once the audio hits this diode right here on pin 5, it comes off the top of that transformer, hits that diode right there, it eliminates the top half of the audio frequency. It eliminates the top half of the audio, so that's gone. That is gone, my friends, leaving us with just the bottom half. And remember, there's no blue in there. Actually, what we've got is like this. I'm not a very good drawer, but like that. Okay, all we have is this bottom half right here. There's no carrier at all. And what happens is once the bottom half of that goes into the tube, it gets amplified out. And when it gets amplified, it gets flipped from the negative side. It gets flipped to the positive side, okay? A tube changes the phase. It does a flip over. It does a flip over. That's what a tube does when it amplifies something. What comes in negative here will go out positive here, okay? So that's all we're going to copy. I mean, that's all we're going to take care of this time. That's all I'm going to talk about this time. Now, one more thing. I think, I'm almost certain, this dotted line right here, let's cover that first. You see this dotted line? What is that dotted line? Well, that dotted line is that little brown little package right there. See it? Right there. See all the little legs on there? Each one is numbered. Let me see. We've got, let me zoom in. Look, there you go. You can see it. It's 1, 2, 3, 4, 5, 6, 7. See them right there? That's each of those wires you see going down through the circuit board. And that corresponds to what you see. Come on, focus, big boy. Okay, that corresponds to right here. We've got 1, 2, 3, 4. And where's 5 at? 5. And there's 6. And there's 7. Okay, that's what those wires are. Now, one time I had one of these go bad. A friend of mine brought it to me. He said, I don't know what I'm supposed to. It wasn't bad. It was actually missing. Someone had taken it out and messed it up. He said, can you do anything for me? I said, sure, that's not hard to build. My gosh, anybody could take a piece of perforated board. And I said, buy a piece of perforated board and just do it. I happen to have a piece on my desk, my workbench, so I just cut a piece out for him. And we just put a bunch of pieces and parts together like this and, you know, put a little foam rubber on the back and some stuff over the top. And we hooked it up the way it shows on, and it worked fine. Worked fine. It was bigger than this, of course. It was much bigger than this. But, you know, we made sure we insulated it real well and tucked it in a little spot. So if you ever have one of these go bad, they're not that difficult to build. Anybody can build one. So here we go. Again, we were showing negative voltage right here. Okay, negative voltage. Okay, here comes the intermediate frequency with the 455, and the audio gets coupled across. The carrier goes this way, this way, this way, this way, this way, all the way over here to ground. The audio comes across, gets rectified right there by that little diode. It's a rectifier, and it gives you just the negative half. It gets amplified, it gets flipped over to positive, and it runs off into this thing called K1. This is K1, okay? It says right there K1. And also, the audio goes down this way to ground, gets picked off by the volume control, comes up through this coupling capacitor inside that K1, comes back out, goes to the control grid, which enables the thing to amplify. Okay? All right, next time. Now, one other thing. Let me see. I'll cover that here in a second. It's going to involve the ABC down through this resistor, which is R4 at 2.2 meg. We'll cover that next. The audio not only comes across here and goes down through this resistor and gets picked off by the volume control and sent up here to control the the amplification of the tube. But it also comes on down this way and goes through this resistor, the audio. We're talking audio now. Remember, the carrier has been removed all the way across here to ground, leaving us with just the audio. Well, of course, there's going to be some carrier on there. You can't eliminate every bit of it, especially not in these old radios. Anyway, it's going to come down through our for this little 2.2 meg ohm resistor. It's going to come across and it's going to be filtered out by this C2 right here. Remember quite a while ago I told you that C2 has many jobs. This is one of them. It's going to filter out the audio, leaving just the voltage. Well, why do we want that? Why do we want just the voltage? The audio comes down. Well, we want it to control the control grid of this tube right here, which is the intermediate frequency amplifier. And we also want it to come down and come up and control the control grid of the converter 12BE6. Now the control grid, of course, has bias voltage of negative voltage here. Remember, we told you bias voltage is negative on the grids, and we have negative voltage here also. With just with the audio gone and the fluctuating voltage changing all the time, depending on the strength of the signal of the radio station and all that jazz, and it comes in stronger one minute, lower the next minute. You remember in the old days we used to have AM used to fade in and out all the time. I think it still does, really. It'll be going along fine, and right in the middle of your best, mostest favorite song, it'll fade out. You remember those days, the old guys do. Still happens quite a bit. But anyway, when that happens, when the signal is low, the tubes here and here begin to conduct more because the bias voltage has changed. And when the tubes conduct more and amplify more, then the volume goes up. Now when the volume gets too high, the reverse happens. The audio comes down, comes across, and it causes the control grids to become further positive relative to the cathode. Anyway, it affects the volume on both tubes. When the volume is high, it pulls the amplification down. When the volume is low coming over here and coming out of this second IF, then it affects the tubes where it increases the volume. I showed this once before. It's like a teeter-totter action, okay? When it goes up and down, this is the front end of the radio. When this side goes down, which would be what's coming out of right here, when the audio goes down, the amplification in this tube and this tube go up. When the amplification, or when the volume goes up, or the strength of the signal goes up, then it causes these two tubes to not amplify so much. Well, what's the big deal about that? Why do we want this to happen? So we don't sit there listening. We're trying to keep the volume at a steady rate. Otherwise, you'd be over there every 5 seconds, turning the volume down, turn the volume up, turn the volume down. This is automatic volume control, AVC. It's just a signal fed back into the grids of the two tubes in the front, which enable them to amplify more or amplify less, which kind of keeps it at an even keel all the way through here until it finally reaches the output tube, which we're going to cover next time. Now, it seems to me there was one other thing I needed to cover, and every time I do these things, I can't ever remember what that other thing is. Let's see if I can figure it out. Oh, I know what it was. I'm going to remove one end of this tube right here. Let me see. This, not tube, one end of this resistor. If I can just get this camera to focus. There we go. This AVC circuit resistor, I'm going to lift one end. And what do you think is going to happen if I do that? What do you think is going to happen if I remove this? What I'm doing by removing one end, either this end or this end, doesn't matter as long as I take it out of the circuit. It's going to, shut down the AVC circuit. What's going to happen to the radio if I do that? I have removed one end of R4, and that's what this is clipped to right here, this end of the gator wire. And then I went ahead and clipped the other end of the gator wire on the other end of the resistor. Now right now, it's still in circuit because I have it gator wired in. So let's go ahead and turn up the volume and remove this gator wire and find out what's going to happen. See if your guess is correct. We got some bad reception in here tonight, by the way. All right, here we go. Let me see, maybe I can get something better. There we go. Okay, there we go. All right, here we go. Off she comes. How about that? It keeps playing. It keeps playing, okay? It almost has no effect. It almost has no effect, but That's because tonight on this particular station it's coming in nice and strong, so it'll be steady. But if this was a weaker station, I was trying to bring it in and it kept fluctuating in and out, it would make a big difference. Let's hook her back up. Oh, must have messed it up there a little. This one here is, there we go. Okay. All right. It actually, on this particular station it had no effect, but the radio does keep playing. So sometimes it's a little bit hard to find that resistor that might be out because the radio is playing. A while back, one of our good subscribers, he said that maybe we could generate some silver mica disease in this radio and kind of show everybody what a radio sounds like with silver mica disease. Well, I didn't know how to generate silver mica disease unless you have it, you know. So I asked him, I said, if you can come up with a way, I'll be happy to do it. Well, apparently, our good buddy Brendan, you know, he always comes through on some kind of an idea. Apparently, he read that comment and he picked up on it. And he said, well, let's try this. Maybe we can go ahead. Let me get a pencil here. I'm not ready again. Okay. He said, maybe we can take here on the second IF, you know, where it comes out of this first IF amplifier. And he said, maybe we can solder a wire here at pin 2 of this IF can, and we can kind of scratch around the other end of the wire on pin 1. Maybe that would give us the sound we need. Well, I tried it. I soldered a wire. Right here it is. I soldered a wire to pin 5, and I scratched around on pin 6, which is, this is pin 5, that's pin 6. I scratched around. Didn't do any good. Didn't do any good at all. We kind of basically got a dead radio. So I kept scratching around, and I found out that if I scratched around on the, where are you? Here we go. If I scratch around on the positive side, just lightly scratch. You don't want to stick your wire on there. But I just lightly scratch around on this 75 microfarad E-cap, the positive side, okay? I just kind of lightly scratch, you know, scratchy, 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 scratchy. It pretty much gave us the sound of what silver mica disease sounds like. So here we go. We're going to let you see it too. It won't be exact, but it's pretty darn close. See if I can get a station here. I had a station a second ago. I wonder where it went. Okay, that's good enough. So let's go ahead. I'm going to take the end of this thing. It's all kind of splayed out, as you can see. I'm just going to lightly scratch, and you'll be able to hear a staticky kind of sound. Sometimes the static is so profound that you can't even hear the station. Other times, you know, it's kind of, you can hear the station coming through. So here we go. That's only it's steady, okay? That's about as close as you're going to get. That's what silver mica disease sounds like. Now sometimes, as I said, the scratches they're just so loud and so long that you can't even hear the station. You'll get about something like this, but it'll be scratching the entire time. You can't hear anything. You know, you'll be tuning your station, trying to find a station, and the whole time it's going to be doing that. Okay, that's as close as I can get it. We'll consider that case closed on the SMD. Well, that's all we're going to cover for today. We've gone through all the way from the converter, through the intermediate frequency amplifier, over here to the detector, automatic volume control, and audio frequency amplifier, all in this one tube. Remember, that's a little diode right there. That takes away half of the audio, the top half, okay? Then it comes over here, and in this particular radio, it goes to one of these packages. I got to find out the name of that thing. See what it calls for on the parts list. Let me see if I can find it real quick here. It may just call it K1. I don't know. Let me see here. Let me see. I've got it right here. I should have already looked it up, but I didn't, like a chump. Let me see here. K1. It's an audio coupling is all there is to it. That's what they call it. Audio. It's used for audio coupling. It's just K1. I figured that. I've heard it called all kind of something, you know, discrete package, component package. I've heard it called all kind of weird things. Anyway, just keep in mind when we pick up next time, it'll be right here on the 50C5. Incidentally, I can't remember if I covered this capacitor right here, but I think when the audio comes out, the amplified audio comes out, it gets coupled through this capacitor to the grid of the output tube. I think they've got one more capacitor right here that's also connected to ground. And that takes away any residual carrier that might still be riding with the audio. Okay, it's kind of a last minute check valve. Get rid of that last stuff. Otherwise you're going to hear it out here. Well, that's it. I hope this has helped. Until next time, this is John.